Yes, good morning to everyone. Uh, this is the block diagram of feedback amplifier. In this, we have the five blocks to perform the amplification operation with feedback connections. In the diagrams, first block is their signal source, and the second block is their mixer network. Next is their basic amplifier with gain A, and a sampling network, and feedback network is there denoted by the factor beta. And what are the functions of these five blocks, and how to perform the operation between input and output, and how to take that variables in between each blocks, right? So they're taking signal source output is Vs, and mixer network inputs are having two. One is Vs and one more is feedback network output, that is Vf. And mixer output is there denoted by Vd, difference voltage is equal to Vs plus or minus Vf. Their mixer is a comparator which compare the two input voltages. One is Vs, another one is Vf, and they are comparing, that is equal to Vd, Vs plus or minus Vf. Once you have to take Vd is equal to Vs plus Vf, and next you have to take Vd is equal to Vs minus Vf. So depends upon the type of feedback connections, you have to take the sign in between Vs and Vf. Next, that Vd is applying to amplifier input, that is the basic amplifier input, and denoted by the gain is A. And amplifier output is getting considered, that is voltage V0, that is there. V0 is considered the sampling network, and that sampling network considered that to sample the voltages, that is there considered that connected to output across load resistor RL. That voltage is get back to input side with the network, that is their feedback network, and the factor is considered their beta. And that output voltage of the amplifier is the input of feedback network, and feedback network output is considered the variable is Vf. So here consider the feedback network is very important block for this amplifier, that is there consider the network formations with the different passive components, that are resistive element, resistors, inductors, capacitors. If you take that network elements are only resistors or only capacitors or inductors, or if you take that network formation with the combination of resistors, capacitors, resistors, inductors, or capacitors and inductors, or like that. So based on that different elements or individual elements network formations, and you will perform the total amplifier circuit operations, right? So finally you have to get that amplifier output voltage something better than the input. But this feedback connections considered here two types, that's are there positive feedback and negative feedback. Already we discussed about the types of the feedback connections in the amplifiers, right? And which is the better feedback connection for the amplifier circuit is that is there negative feedback connection is better, because that feedback, that is negative feedback characteristics is better or suitable for the amplification operation compared with the positive feedback connections, because that negative feedback connections in the amplifier circuit, the gain is decreased or reduced, and the bandwidth is increased, noise and distortion is decreases, and stability operation is maintained in between input and output. So these are the some important points considered for the characteristics of that feedback types, right? So that negative feedback is better to for the amplification operation in the amplifier circuit compared with the positive feedback, right? And first we have to know about that all blocks. What is the mixer network, right? What is the function there? What is the basic amplifier, and what is the feedback network, and what is the sampling network functions? For that, yes. Now we have the four blocks of the block diagram functions here. Signal source. What is the signal source is? The signal source can be a voltage source. They are denoted by Vs. It is a voltage source in series with the resistor Rs. Right? We have the actually amplifier input sections. Vs is connecting in series with the Rs. Right? In the previous circuit diagrams, consider there source resistance is connected in series with the source voltages, or it can be a current source Is, right, with parallel resistor Rs. So based on the source consideration, you have to take the resistors connection, that is in series or parallel. So that is the source signal source. Next, feedback network is a feedback network is a linear two-port network that contains resistors, inductors, capacitors. I said that it's are having network formations. That network components consider their only passive components, either in a single, individual, or combinations. That's why here also consider that it contains resistors, inductors, capacitors. Its function is to feed back some portion of the output to the input, right? So feedback is a connection that is used for it take some portion of the output voltage fed back to the input. That is the feedback network. Next, sampling network. These are basically two types. Sampling network basically two types: current sampling network and voltage sampling network. One is current sampling network, and second one is voltage sampling network. The output voltage is sampled when we connect feedback network in either shunt or in series with the output. The output voltage is sampled when we connect feedback network in either shunt or in series with the output, right? So this is the sampling network, right? Sampling networks are basically two types: current sampling network and voltage sampling networks. Next is mixer. What is the mixer is in the block diagram? Mixer circuit is also known as the comparator. It can be a series mixer or shunt mixer. So here also consider that block. It is a mixer is a comparator circuit or comparator network. It can be a series mixer or shunt mixer. It mixes the signals, source signal and feedback signal. The mixer network mixed or mixing or combine the source signal and feedback signal. That's why I said that Vs plus or minus Vf. Vf is the feedback signal and Vs is the source signal, right? Their consideration either positive or negative. If you take the positive, that feedback connection is a positive feedback. If you take the negative, that feedback connection from output to input is negative feedback. So that is equal to Vd, right? So these are the block diagram, each block's functions considerations here, right, for the amplifier operations, feedback amplifier operations. That is the block diagram representations, right? Next is here operation of feedback amplifier. In these black diagrams, we have to get the gain of the amplifier with feedback and without feedback, right? So there we have the two blocks, and a mixer point is there, output signals, input signal there. So let us have to look at the diagram shown below. Here we are talking about the general condition in which we are providing feedback to the input. It can be a positive feedback or negative feedback. And one more is there, Vs, source signal, is applied to the amplifier with gain A that produces a amplified signal V naught, right? Same things there, Vd is equal to Vs plus or minus Vf, and Vf is equal to beta V naught. Beta is the factor, V naught is the amplifier output, right? And what is the gain of the amplifier, right here? So some signals given there, the summer or mixer that resultant produces either a sum or difference of the two signal depending on their phase relationship. The gain of an amplifier is given as the ratio of output voltage or current to the input voltage or current. What is the gain of the amplifier is that. So for the above figure, the gain of the circuit without feedback is given as, we have the two gains considered from that amplifier circuit. One is with feedback and one more is without feedback. Now the equation 1 is gain of the amplifier without feedback. So there gain denoted by A is equal to, for amplifier, A is equal to output voltage to input voltage. See, in this ratio we have the variable V0 and Vd. Vd is the amplifier input voltage, that is mixer output voltage, right? In this equation, Vs is not considered in the denominator because this gain is only for amplifier gain, not feedback amplifier, right? So in the black diagram we have two blocks, one is amplifier and one more is feedback. For this gain, equation 1, A is the gain. That equation doesn't consider the feedback network connection, so only considered amplifier block, and the gain is considered their output voltage and input voltage, that is Vd. Next, the gain of feedback network. Equation 1 is gain of the amplifier and next is gain of feedback network. What is the gain of the feedback network? The equation 2 is given as factor denoted by beta is equal to Vf by V0. Vf is the feedback network output voltage and V0 is the amplifier output, that is feedback network input voltage, right? That is the, this is only feedback network gain, equation 2, and equation 1 is only amplifier block gain. Next, but as we can see, Vd is the mixer output voltage given by, what is Vd? Vs plus or minus Vf. Vd is the comparator, that is the mixer and mixed the two signals, that is Vs and Vf. They are considered the two signs in between the two variables in equation 3, right? Next, the signal voltage Vs and mixer output voltage Vd will only be equal in a feedback amplifier. Vd and Vs is equal there unless the output is not generated, right? So this point is very important. Vs and Vd will be only be equal in a feedback amplifier unless the output is not generated, right? We have the three equations from the amplifier's individual blocks. From the three equations we will get the overall gain of the amplifier, that is feedback amplifier, not only amplifier, feedback amplifier, right? For that we have to take the equation 1. We can write there from that equation 1, that is V0 is equal to AVD. V naught is equal to AVD. Cross multiplication there. That is the equation 4. Substituting the value of VD in equation 4. What is the equation VD? Third equation is VD. That equation is substituting in equation 4. We have V naught is equal to A of VD. In the place of VD, we have to take Vs plus or minus Vf. That is the equation 5. Next, from equation 2, what is the equation 2? Gain of the feedback network, that is Vf is equal to beta V naught. Now that is the sixth equation. Substituting the value of Vf in equation 5. For that we have to take V naught equation, that is the equation 5. V naught is equal to A of Vs plus or minus beta V naught. In the place of Vf we have to take beta V naught. Next, V naught is equal to AVS multiplication, bracket inside, AVS plus or minus A beta V naught. Right? From that equation, V naught is equal to AVS plus or minus A beta V naught. From that equation, we have to take the same variable one side, right? That is there. V naught plus or minus A beta V naught is equal to AVS. From that equation, the left side terms there, V naught taking outside in the two terms, that is V naught of 1 plus or minus A beta is equal to AVS. Next, in that left and right equations, we have to take the ratio variables, that is V naught by Vs is equal to A by 1 plus or minus A beta. Now, V naught is output voltage of amplifier with feedback. Vs is the input signal voltage, that is the source voltage. Now the two ratios are overall amplifier gain with feedback. So there AVF or AF, voltage gain with feedback, is equal to A by 1 plus or minus A beta, where V naught by Vs is equal to A Vf, that is equal to A by 1 plus or minus A beta, right? So in the denominator we have two signs, one is plus, another one is minus, right? Here not consider the positive feedback and negative feedback. Here consider the just feedback connections with the amplifier circuit, right? That's why there plus or minus two signs. If you consider that feedback amplifier is a positive feedback or negative feedback, you have to get the denominator is only one sign, either positive sign or negative sign, right? Suppose if you take that amplifier feedback connection is negative feedback connection, or that is a negative feedback amplifier, the gain of the amplifier with feedback AVF is equal to A by 1 plus A beta. For the negative feedback, you have to get that gain with feedback is A by 1 plus A beta. For positive feedback, you have to get that gain with feedback AVF is equal to A by 1 minus A beta for positive feedback amplifier. One denominator 1 minus A beta. So this is very careful to take the denominator signs, plus or minus. For positive, you have 1 minus A beta. For negative, you have to get the denominator 1 plus A beta, right? In the next is there here, this is the desired value for the gain of the feedback amplifier. Here not mentioned negative or positive, just gain of the feedback amplifier, that is. Next is the gain of an amplifier is always greater than 1. The gain of an amplifier is always greater than 1. This simply means that some elements are present which increases the gain of the amplifier. That element can be a transistor or a MOSFET. So here the gain of the amplifier always greater than 1. That is their A beta values, because the generally consider the beta value is 20 to 400, I said in the previous classes. So multiplied with gain, you have to get that A beta value is more compared with 1 value, right? And next is uh, here consider that uh, type of feedback connection, that is their positive feedback connection or negative feedback connections, right? So based on the type of connections, that is the type of feedback connection with the original input signal, we have to get the equation there, right? See that in this last sentence given there, or last second sentence there in this diagram, as we have discussed earlier that in case of a positive feedback, yes, positive feedback, the source signal will be in phase with that of feedback signal, right? Positive sign considered between Vs and Vf, you have to take that in phase with that of feedback signal. Thus, the mixer will produce the summation of the two signals applied to it in case of positive feedback. For that, we have to take that block diagram is this. Vs is combined with Vf. That's why their summing output, that is the mixer output, Vs plus Vf. That is the amplifier input, and you have to get the output is V0. So with that block diagram, you have to get that gain of the amplifier with feedback AVF. The gain of the amplifier is given as with feedback AVF is equal to A by 1 minus A beta. I said that for positive feedback connections, you have to get the denominator 1 minus. For positive, getting negative 1 minus A beta. This is the gain for a positive feedback amplifier. And next is negative feedback. There given the sentence, thus the mixer circuit will resultantly produce the difference between the two signal in case of a negative feedback amplifier. So you have to take the summing, that is the mixer point output is Vs minus Vf, minus negative sign there for negative feedback. That is amplifier input is Vs minus Vf and output is V0 and feedback output is Vf. Here given that. So in this case, the gain of the amplifier is given as AVF with feedback is equal to A by 1 plus A beta. For a negative feedback, the value of denominator is always greater than 1, right? So here denominator sign is positive for negative feedback connections. Okay, so these two equations are very important for the problematic is also. First, derivation is very important. So they will ask the question, derive the gain of the amplifier with feedback. Gain of the amplifier with feedback, right? And you have to get that all equations, and finally you will indicate in the block AVF is equal to A by 1 plus or minus A beta. Sometimes they will ask derive that gain of the amplifier with negative feedback or with positive feedback. You have to take these two equations based on that negative or positive feedback connections, right? Next is here already we discussed about that gain. So what happened in the gain in the amplifier, because the feedback connection considered for the amplifier is negative feedback, so the gain is reduced.